Now moving forward, let's take up the next one, that is question number 7. This is from section 2, which has multiple answers correct. Let B be a non-zero real number. Suppose f from R to R is a differentiable function such that value of the function at 0 is 1. If the derivative f dash of f satisfies this equation for all x, then which of the following statements are true? Questions option are involving about increasing decreasing nature and some functional value. So let's begin with this equation, which is saying f dash x is equal to fx upon b square plus x square. Let's consider fx as y, so you actually have dy by y is equal to dx upon b square plus x square. Integrating both sides, you get log mod y is tan inverse x by b multiplied with 1 upon b. Correct? Now when you eliminate this log, you also have plus constant of integration, right? When you eliminate this logarithmic, you are getting simply mod y is equal to e raised to the power 1 by b tan inverse x by b plus c. Now it is given to me that the value of the function f at 0 is 1. Correct? So put the value of x as 0 and y as 1. Since f0 is 1, you are getting c as 0. Correct? Because when you say this is 0, this is e to the power c is equal to mod 1. That gives you simply 1. That means c is 0. Now your function is ready. That is y is equal to e to the power 1 by b tan inverse x by b, or y equals minus e to the power 1 by b tan inverse x by b. Now since it is given to me that the value of the function at x is equal to 0 is 1, so obviously this is not the correct option. This is the only possibility we are left with. So that's the only function with me. When you look at this function, this is exponential function. Take its derivative in order to see the increasing decreasing nature, which is already given in the function as dy by dx is this one. Right here fx. What is that fx we obtained? This is e to the power 1 by b tan inverse x by b. So on writing, you have 1 upon b square plus x square into e to the power 1 by b tan inverse x by b. This is simply f dash x. Clearly this function is increasing. This is positive for all values of b, meaning fx is increasing for every b. Option 1 says that when b is positive, f is increasing. Yes, in fact it is increasing for every value of b. Second option says b is less than 0, then it is decreasing. No, again in that case it is increasing. Third is talking about product of fx and f of minus x. Let's plan. Fx, that is y, f of minus x is equal to what we observe, e to the power 1 by b tan inverse x by b plus 1 by b tan inverse minus x by b. That means this is e to the power 0 or simply 1. Yes, we can see now from options that option C is also correct. When you add the two, obviously it is not 0, so this is also wrong. So we observe here the correct options for this question are option number A and option number C. I'm sure this question is clear. Alright, so let's mention our correct options A and C, first and third. Moving on to the next question, that is question number 8. Let A and B be positive real numbers such that A is greater than 1 and B is less than A. Let P is a point in the first quadrant that lies on the hyperbola this one. Here B is less than A. Suppose the tangent to the hyperbola at P passes through the point 1, 0, and suppose the normal to the hyperbola at P cuts off equal intercepts on the coordinate axis. Let delta denote the area of the triangle formed by the tangent at P, the normal at P, and the x-axis. If E is the eccentricity, then which of the following statements are true? 2 options are talking about eccentricity and 2 are talking about area of the triangle. So let's understand first the geometry of this question, that what is required. Coordinate axis. Now hyperbola, you can draw just one branch or both, not going to make any big difference. Question says there is a point P in the first quadrant, let's say here. Now the tangent is drawn at this point and normal is being drawn. Let's consider first the tangent at this point like this, and then consider a normal at this point like this. Correct? This is perpendicular because we have drawn tangent and normal. Now this tangent is passing through the point 1, 0, so this point is 1, 0. We can take this point P on the hyperbola as a sec theta, comma b tan theta. A point can be taken on the hyperbola a sec theta, b tan theta. This is clear? All right. We can write the equation of tangent and normal at point P. Tangent at P. This is simply x sec theta upon a minus y tan theta upon b is equal to 1. This is clear? It is passing through 1, 0. Since it is passing through 1, 0, so on substituting 1 and 0, what we observe? Sec theta upon a is 1. That means a is sec theta. This is one important result. Next, normal. Normal at P. This is given by ax by sec theta plus by by tan theta is equal to a square plus b square. It is cutting off equal intercepts. Obviously, from the figure we can understand that when cutting equal intercepts, the slope of the normal is -1. So equate the slope of the normal obtained from here with -1. We can see here it is minus a by sec theta into tan theta by b. This is -1. Since a is sec theta, so these two terms are cancelled. Minus is cancelled. We are getting b equals tan theta. This is another important result. Now, we have to talk about eccentricity. Eccentricity is root of 1 plus b square by a square. That is tan square theta by sec square theta. Or we can say this is equal to root 1 plus sine square theta. Clearly, eccentricity is lying in the interval 1 to root 2. Minimum possible value approaching to 0, maximum possible value approaching to 1. So this gives you the result as E is lying in the interval 1 to root 2. Now time to check from the given options. 1 to root 2 is given here as option number 1. So yes, let's mark as the correct answer. Next, we have to talk about area of the triangle. We have this point 1, 0. This is the intersection of normal. When you put y equals 0 in normal, meaning this point is a square plus b square comma 0. We can write the area of triangle now, half base into height. Therefore, area of the triangle, this is half base, meaning a square plus b square minus 1 into height, that is b tan theta. Just replace a and b with sec and tan. Later we will change back into a and b because sec tan it is easy to handle. Half sec square theta plus tan square theta minus 1 into tan square theta. So we can see sec square theta minus 1 is tan square theta. So 2 will be cancelled. We are getting tan 4 theta, or simply b to the power 4 because tan theta is b. Now time to check from the given options. Area of triangle equals b4. It is given here as option number D. So yes, this is also correct. So correct options for this question, these are A and D. I'm sure this question is clear. Time to take up the next one, that is question number 9. Let f and g be two functions satisfying this equation and this one for all real values of x and y. limit x approaching to 0, gx is 1. Then which of the following statements are true? 4 options are given based on differentiability and derivatives value of the function f and also differentiability of g. Let's deal with it. We can start the question like f dash x, because when the functional condition is given, we have two possibilities. One, we can start by taking derivative of this equation, partial derivative with respect to x, then replace x with say 0 and y with y. Or option 2, go with first principle. I'm going with first principle right now. Limit h approaching to 0, f of x plus h minus fx upon h. So this is equal to limit h approaching to 0. Applying property f of x plus y given to me, that is fx plus fh plus fx fh minus fx divided by h. Fx is cancelled. What we are left with? Fh plus fx into fh upon h. So limit h approaching to 0, fh by h into 1 plus fx. Now look at the given question again, if something can be obtained from there. Limit x approaching to 0, gx is given to me 1. And what is gx? Gx is obtained from here as fx upon x, meaning limit x approaching to 0, fx upon x is 1. Alright. Limit h approaching to 0, fh upon h, that is simply 1. So yes, we obtain finally, therefore f dash x is equal to 1 plus fx. Take this 1 plus fx into denominator. So you have log mod 1 plus fx is equal to x plus c. This is clear? We have to find c. When you say x is 0, what is f0? Can we describe? Let's try. From this equation, when you put x and y both 0, you are getting simply 0 is equal to 0 plus f0 into f0. So f0 1 cancelled, possibility looks like 0 or minus 1. Or from this equation, not this obtained one, which was obtained with the constraint that x is non-zero. When you look at this option, you are getting f0 is 0 into g0. You have limit x approaching to 0, gx is 1, so yes, f0 is 0. So let's write down, this is 0. Therefore, 1 plus fx is plus minus e to the power x. Now since f0 is 0, so obviously minus sign will be discarded. Negative, not possible. So we are getting finally fx, and what is that? Therefore fx is e to the power x minus 1. This is my function. Now the function is obtained, time to go for the options. F is differentiable at every real value of x. This is true because the function ex minus 1 is differentiable everywhere. This is talking about g, we'll talk later. The derivative f dash 1 is equal to 1. What is the function? Function obtained is fx is equal to ex minus 1. What's the derivative? Ex. So when you put here x is equal to 1, you are getting e, meaning option C is not correct. F dash 0, yes, the derivative is 1. Yes, derivative is 0. This is correct. Now we have to talk about option B, which is talking about g. Gx is fx upon x. So obviously it is not defined at 0. But if you define g0 1 separately, what is going to happen? Let's check out. So gx is ex minus 1 upon x when x is non-zero, and let's define 1 when x is 0. So clearly it is differentiable everywhere, only point of concern is x equals 0. So now we need to find the derivative. Let's go for right hand derivative of g at 0. this is limit h approaching to 0 e to the power h minus 1 upon h minus 1 divided by h. Taking LCM and expanding e to the power x, we have limit h approaching to 0, 1 plus h upon factorial 1, h square upon factorial 2 and so on, minus 1 minus h divided by h square. We can see that 1 plus h and minus 1 minus h are cancelled. From rest we take h square common. This is coming to be half. In the similar fashion, we will be obtaining left hand derivative at 0, that will also come as half. So yes, it is differentiable everywhere now if you define G0 as 1. So this option is also correct. That is option number B. So let's mark and mention final answer as A, B, D. I'm sure this is clear. Time to take up the next one.